Welcome to Partial Fractions, another of your integration review videos. So the idea here is we know that if we have an integral of, say, 1 over a linear term, mx plus b dx, we know that we can take this integral. This winds up being 1 over m times the natural log of the absolute value of mx plus b. So as long as we have a linear factor and then our plus c. Sorry, that got a little low there. So as long as we have our linear factor, we just have a natural log when we have a 1 over. But if we have a higher degree in the denominator, and U substitution doesn't apply, then sometimes partial fractions can be useful. So if U substitution doesn't apply, then separating out in partial fractions is useful. So I'm just going to do an example of this instead of trying to explain the strategy first. So if we wanted to take the integral of 3x plus 2 over x squared minus 3x minus 10, we're first going to just focus on the fraction inside. So 3x plus 2 over x squared minus 3x minus 10. We could go ahead and factor that denominator. We will have a 3x plus 2 up top. And down below, this factors as x minus 5 times x plus 2. So essentially what we're going to do is we are going to assume that we can split this fraction as a over x minus 5 plus b over x plus 2. And then our job will be to solve for b, a and b. So if we that looks like a plus b. This is a and b. If we rearrange these, like essentially combine the fractions again, then the numerator on the right should match the numerator on the left. So if we have 3x plus 2 over x squared minus 3x minus 10, giving a common denominator on the right, we would have a times x plus 2 plus b times x minus 5 all over x squared minus 3x minus 10. And so what we have then is that 3x plus 2 is equal to a times x plus 2 plus b times x minus 5. The trick here is to plug in the values of x that make one of your factors 0. So we're going to first plug in x equals negative 2. And what we therefore have is we have 3 times negative 2 plus 2 is equal to a times 0 plus b times negative 7. And so we have negative 4 is equal to negative 7b, or b is equal to 4/7. Then we'll do the same thing, making the other factor equal 0. So now we will go ahead and plug in x equals 5. Plugging in x equals 5, we have 3 times 5 plus 2 is equal to a times 7 plus 0. So this becomes 17 equals 7a, where a equals 17/7. So essentially what we can do now is we can just rewrite the original integral with these split fractions that we have just found. So we have then that our original integral of 3x plus 2 over x squared minus 3x minus 10 dx is equal to the integral of a was 17/7 over x minus 5, and then plus 4/7 over x plus 2 dx. And then each of those is essentially a 1 over a linear factor. And so we can do our standard integration with natural logs. We get 17/7 times the natural log of absolute value x minus 5 plus 4/7 times the natural log of the absolute value of x plus 2 plus c. If you wanted to do some manipulation, you could, but this is more or less what we get doing our partial fractions. If you have more than 2 factors, you just split it up into 1 fraction per factor for your denominator. And then again, just plug in whatever will make one of those factors go to 0 to do your integration, or to do your splitting into fractions. There are a few more complicated cases. If you have sort of either nonlinear factors that cannot be factored or repeated roots, but we will not be worrying about those in this video. So again, there are complications. If the denominator has nonlinear factors, or repeated roots, but we will not worry about those for now. So that is integration using partial fractions.